Hi, welcome to Mat210, and we're going to talk about average rate of change. And this is where we actually are going to start to do some calculus. And in the next few lessons, we're going to tie in the idea of limits, which we talked about but probably didn't understand, and the average rate of change, which we're going to tie in. And we're going to do a whole bunch of algebra, and it's going to be like the most exciting thing ever because this is the best part of it, or one of the best parts of calculus. We're going to actually start doing some real calculus. So let me start out with a little graph here and see if I can help you explain what the average rate of change is. Okay, let's suppose we have a curve and it goes through a couple points. I'm going to draw this curve, just a nice curve, and it continues up here and here. Okay, so we have this nice, beautiful curve right here, and we have a line that connects through these 2 points. This line right here is called a secant line. A secant line is a line that passes through 2 points on a circle, basically. You might remember this from geometry. So if you had a circle and you had 2 points, and there's a line that goes through it, it's called a secant line. If the line goes right through the center of the circle, then that secant line became the diameter, right? So that became the diameter of the circle. And if you have a line that just barely touches the curve at one point, that's called a tangent line. Tangent. So right now, this is a secant line. This is also a secant line. Okay, so that's what a secant line is. It's a line that goes through 2 points on a curve. Okay, and what we're going to do gradually, not completely today, but in the next lesson, we're going to turn this secant line into a tangent line. We're going to get this line closer and closer and closer and closer so that it just barely touches this circle. Okay, so thinking of this as just a straight line, the distance, the rise over the run is called the slope. And that's very important because we're going to talk about average rate of change. Average rate of change is simply the slope of the line. You know, you can make it, I remember when I went to calculus, it's like, I didn't know that, it's just the slope of the line, m. That's all it is. That's what we're going to try to find. But on a curve, you see the slope keeps changing. If we go to different points on the x-axis, then the slope is different all the way through on this curve. If we have a curve that looks like this, it's constantly changing. Our slope could be here, and then our slope could be here. The slope is the tangent line to the curve, and it keeps changing. And what we're going to do in calculus is we're going to come up with a universal formula for each curve to find the slope at any point. Now, in a straight line, it's easy. We come up with a number. Like the slope here could be 3/4 or 2/1 or a half or whatever. But in calculus, it's more like a formula. And our job is to find that formula. So we're going to do a little investigating. So normally we would call this point right here, that if we projected down on the x-axis, this would be x, and this point right here would be x of 1. But we're going to use a little variation on it. This distance between these 2 points, what is that distance? Well, we're going to call it h. the distance that it goes between these 2 points is called h. So rather than calling this x1 and maybe this point x2, kind of show it different, we're going to call this point x, and we're going to call this point x plus this distance, x plus h. So we're going to use those as our thing. And again, this would normally be y1. This would probably be y2. Okay? And we're going to go up the same amount of distance. The distance here is going to be h also. Okay? And normally we would call this y sub 1, but we're going to, because this, and it took me a long time to figure this out, like a whole year of calculus, to figure out f of x and y are the same thing. Sometimes we can put in, so they could call this the y-axis or the f of x axis. So this really stands for the point x1, y1, but it also could stand for the point f, x. Instead of calling it, let's put it down. I'm going to get this all messed up. But we're going to call this, instead of x1, y1, we're going to call it f of x, f of x. That's what the name of this point is. Just because it's calculus, we make it hard enough. And then what about this point? Well, this point is going to be from, the y is also increasing, just like the x did. This was x plus h. This is going to be y plus h. But we're not going to call it y plus h. We're going to call it f of x plus h. We could have called it a y plus h, but it would have been easier to do it that way, but we call it f of x plus h. So do you remember your slope formula? M was the change in x's, x2, x sub 2 minus x sub 1, but where was on the top? It was a change in y over the change in x, y sub 2 minus y sub 1. There was your slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember that formula? From algebra a long time ago. Well, in algebra, you probably got it, forgot it, who cares? But in calculus, it's extremely important because everything we do, the derivatives and everything, depend on the slope. But we're not going to call it y sub 2. What are we going to call it? Instead of this being y sub 2, let's call this point right here is x plus h, comma, function of x plus h. That's what the name of that point's going to be. I hope you can see this. It's getting kind of small. I shouldn't have made it so small. Okay, so let's define our slope. Let's make this a little bit bigger. Y sub 2, function of x plus h, minus y sub 1, function of x, y sub 1, function of x, over x sub 1, x sub 2, which is x plus h, minus x sub 1. So in place of y sub 2 would have been function of x plus h. Y sub 1 would have been function of x plus h. Well, let's simplify this. This would be function of x plus h minus the function of x over, these are cancel out, h. Yes, and this is what we call the difference quotient. Your first step in doing, we can make that a capital D, make it real pronounced. The first step in doing calculus. The reason it's called difference quotient is we're finding the difference. The difference means subtract, and we're dividing by h. Now, later on, we're going to bring in the idea of limits into this. But right now, we're just going to work with our difference quotient to solve some problem and see how it works. Okay, you may have seen this before on one of the exercises we did, but now we're going to do it in living color. Okay, so we got function of x equals x squared And the question is, find a simplified form of the difference quotient. Find the difference quotient for this problem. And it was pretty much the slope, a formula for the slope of this thing. You're saying, well, because this formula for the slope is going to give us our first derivative. And we'll get into that a little bit later, jumping ahead. So it's all kind of ties together, but right now you're just seeing little bits of the picture. So here's our thing. We're going to find our, so the first thing we want to do is find our f of x plus h. And what we're going to do is substitute that into this problem. So that would be, we're going to put the x plus h into this problem right here, a function of x. So that gives me x plus h squared. And we're going to expand that out. What would that be? Well, let me show you something else, because we're going to be using it. When you just had x, it's 1. When you have x plus h, it's a square double square, isn't it? X plus h just by itself would be 1 and 1, the coefficients. What if I have x plus h squared? What's the expansion of that? X squared plus, remember I showed you a little shortcut, multiply these together and double, 2xh plus h squared. Or you could do a FOIL, you can multiply x plus h times x plus h. And that'll give you this answer. But see, look at here, 1, 2, 1. Those are the coefficients, 1, 2, 1. When I do x plus h to the third later on, it's going to be 1, 3, 3, 1. How do I get those numbers? I just add these together. Add these together. This is called Pascal's triangle. It helps us do expansions like this. And we can do any power. This would be x to the third. It doesn't give us the x's and the h's, but it gives us the coefficients 1, 3, 3, 1. X plus h to the fourth is 1, 4, 6, 4, 1. Those will be your coefficients. And you notice we have 5 terms. When we have x plus h squared, we have 3 terms. X plus h to the third is going to give us 4 terms. Some algebra for you. And we'll be using this a little later, but I diverse. Okay. So anyhow, this expansion is x plus h squared. So now what about our difference quotient? What's our difference quotient? X times function of x plus h minus function of x over h. I should circle that. That's our difference quotient. So we know what x plus h is. X plus h is x squared plus 2xh plus h minus f of x. Here's f of x minus x squared. See, here's your minus function of x over h. Now we're going to simplify that down and we should be done. See this x squared, this negative x squared, they cancel out. If you're doing it correctly, all the terms that don't have h's in them will cancel out, leaving only terms with h's. Now, we got 2xh plus h, simplify it. Let's factor out an h. 2, this should be h squared. There we go. 2x plus h. I wrote it wrong. See, this should have been x squared. Square, double, square. Okay, sorry about that. So we're going to factor that out. These get canceled off. And we're going to put this over h. Cancel it out. Voila. 2x plus h. And there's our kind of a beginning of the slope of this particular equation. Not quite there yet, but this is our difference quotient right now. We're going to refine it in the next lesson. But right now, pretty exciting. We have found a difference quotient. Okay, let's try another one. I'm going to put this up here. We're going to need it. Function of x equals x cubed. First, step one, find f of x plus h. F of x plus h equals x plus h cubed. X plus h cubed is our 1464, no, our 1331 pattern, x cubed. So let me show you how this works. This is going to be x cubed, 1, plus 3. The x's are going to get smaller. The h's are going to get bigger. Plus 3. 1331. 3, x's get smaller, h's get bigger. Plus 1, x's become 0, 3, 2, 1, none. H's become bigger, 1, 2, 3. Now, if you don't want to do it that way, just multiply x plus h times x plus h, get an answer, and then multiply that by x plus h. And this is the answer you will get. That is x plus h. Now let's find the difference quotient. The difference quotient is f of x plus h minus f of x. This is close to doing the very first derivative. Excitement over h. So this is going to be x cubed plus 3x squared h plus 3xh squared. Also, if you're doing calculus, get used to writing minus the original problem, f of x. That's what we're subtracting off, all over h. Now, if we did it right, this term and this term should cancel out, and we'll factor out an h. I'm just going to go ahead and do it right now. 3x squared plus 3xh plus h squared over h. These h's will cancel, get rid of your denominator, and now you have 3x squared plus 3xh plus h squared. And that you have used a difference quotient. We put a little disclaimer, h cannot equal 0. And we have calculated out this problem. Pretty exciting, huh? So this is your difference quotient. I was just checking if it's right. And that's how they got these numbers. Pascal's triangle, I put it down here. 1, 2, 3. See, 1 and 1 is 2. And that would be for x plus h squared. There's your coefficients. X plus h cubed, 1, 3, 3, 1. X plus h to the fourth, 1, 4, 6, 4, 1. You could also use it some Plunkel. And when you drop those balls and they bounce around, bomb, 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 bomb. If you dropped, how many balls would be here? Let's see, that's 10, 14, 15, 16. There's 16 spaces. You have 6 chances out of 16 that it would go into that. 4 out of 16 in here, 4 out of 16 in here, 1 out of 16 in the ends, 1 out of 16. Have you done Plunkel? See, Pascal was very big on probability, and that's what he was trying to do, is develop probability. And this algebra is involved in developing probability. So there's a correlation between algebra, statistics, probability, calculus. It's a foundation. And there we got it. Okay, you're saying, yeah, Mr. Mitchell, that was pretty cool. But give me a hard one. I know you're asking for a hard one. So let's try this one. How many we got enough room here? Let's see if I can write a little bit bigger too so you can see it. function of x equals 1 over x. Not that hard, huh? Okay, let's find out what f of x is plus h. That would be 1 over x plus h. Huh? Cool. Now, what's our difference formula becomes f of x plus h minus f of x. See, you want to get in the habit of writing this down. You're going to remember it. So it's f of x plus h, 1 over x plus h, but minus the original problem, 1 over x. And then I'm going to just put off to the side, divide by h on this one, because if we put it all over h, it's going to be really messy. So I like to write it like that myself, just divided by h. Okay, simple it up. Let's simplify it. Oh, you forgot your algebra. You got to look deep in your brain and see if you can find that algebra somewhere there. Okay, I'm going to show you a little shortcut, crisscross applesauce. Remember they did these problems and you thought, who cares? Well, now you do. Okay, we're going to multiply it diagonally down, x. We're going to multiply diagonally up, minus x plus h, that quantity. And now we're going to multiply the two denominators, x times x plus h. Criss, cross, applesauce. Criss, cross, applesauce. Okay, now we've got it. We're going to distribute that, and this is divided by h. So if I distribute it, let's see if I got enough room, x minus h over, I'm not going to multiply this out because I'm going to see what happens. Okay, these x's cancel out. See how that is? And then we're going to divide this by h. Well, dividing by h is the same thing, fraction, as multiplying by 1 over h. See all this arithmetic and algebra and stuff? So I see I have an h on the bottom, h on the top. Those are canceled. And now I have negative 1 because I had this negative 1h. Negative times 1 is, excuse me, negative 1 over x times x plus h. And we have just solved the problem. So what you're going to find out in calculus is you're going to learn algebra. You're going to learn a lot of algebra. You might not learn too much calculus, but you're going to learn algebra. See, because the problems involve so much algebra that you probably forgot or were not so great at. You thought you were good. X, we're going to work with lots of fractions. We're going to work with fractional exponents, negative fractional exponents, negative fractional square roots of all kinds of terrible things. Okay, so this is how we do it. Criss, cross, applesauce when you have fractions. Let's try another one. Last one, kind of get out of here. Let's try this problem right here. Another interesting problem. Function of x. And of course, they might try to trick you just by saying y equals x. In this case, square root of x. So we're going to write as function of x equals x. Function of x plus h, what is that? Yeah, that's the square root of x plus h. Okay. And then we're going to find that difference quotient. And don't forget this is over h. So this would be the square root of x plus h minus the square root of x over h. Function of x plus h, function of x, h. Pretty cool, huh? But they don't like h's in the bottom. If you notice all these problems, get rid of that h. There's another one. Bingo, get rid of the h. Bingo, get rid of the h right here. You leave it like in this form, but get rid of this h right here. They don't like them. So how are we going to get rid of that h? Now, in the book, it says, if you have your book, it says page 127, it says, algebra is simplification of the difference of each two, boom. Back in the old days when I took calculus, they used to write QED. And then they would write the answer, like on a problem like this. They would write this problem right here, and then they say, leave out all this stuff and write QED. What is QED? Quite easily done. Well, we saw that wasn't quite easily done. We had to do a whole bunch of algebra. But they always left that up to the student. Okay, so how do we do this? How do we quite easily get rid of this h? We're going to use something called rationalization. Now, you're used to rationalizing the denominators, but now we're going to rationalize the numerator. And, it's weird, but it's, so how do we rationalize? Do you remember rationalizing? We had a radical, and we had another radical, and we multiplied it by the opposite sign, plus. And we do the same thing to the bottom. That's called rationalizing. Normally we do it to the denominator, but here we're going to rationalize the numerator. Now, do you remember your difference of squares? Let's look at this problem as a minus b times a plus b. You remember ever seeing that? A squared, we could do the whole thing, plus ab, then the whole thing here, minus ab, minus b squared. These cancel out, and you got a squared minus b squared. Remember that? Okay, we're going to do the same thing here, except we're going to just call it a squared minus b squared. So radical x plus h times radical x plus h gives me, radical x plus h, let's put it down here, radical x plus h squared. What is that? Well, that's just x plus h. So radical x plus h times radical x plus h is just x plus h. Then we could do the outside and the inside, but they're going to cancel. And then we're going to do the last term times the last term, and that's radical x squared, which is minus x, over h times this whole big mess. But watch what happens here. X minus x, gone. Add up to 0. And now you have h over h times the square root of x plus h plus the square root of x. And here the h's cancel, but you need a 1 up there. So here's our final answer. 1 over x plus h plus square root of x. Now you know what you got yourself into. And there's your difference quotient, dq. Makes me kind of hungry doing these problems. All right, so there's your difference quotient. I hope you enjoy it. You have to practice some of these problems. You have to practice these because you've got to get that algebra down. I've kind of showed you some little things with algebra. We've seen the pattern, a minus b times a plus b, right? You can do a short FOIL, first times first, minus last times last. We did this one, a minus h squared, a squared multiplied together, double, square. We did a minus h cubed, a cubed minus 3. You can almost think of the power being 3. A squared h. I wonder if these have alternating signs. I think it's just minus. Minus 3a h squared minus h cubed, I think. But I think the signs alternate. That this is a cubed minus plus minus. Let's see, we got, well, let's take a squared minus 2ah plus h squared and multiply it by a minus h. A cubed minus 2a squared h plus ah squared. Now by the minus h. This would be minus a squared h. Now by the minus 2a. This was a minus. Wait, get ahead of myself. So if I multiply this by minus, yes, a minus times a minus is a plus 2ah squared. And then find it a minus h times ah squared is minus h cubed. Yes, they alternate in signs. So it's the signs alternate. Plus, minus, plus, minus. And if, on the plus side, we didn't have to worry. But if there's a minus sign, they're alternating signs. See right here, plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus. So it kind of proves it. I should have finished this problem. Okay, there we got it. All right. Oh, you couldn't even see it. Well, I'm sorry about that. But anyhow, the signs do alternate. Okay, the signs alternate. So you want to be careful. You're going to have loads of fun doing all this algebra. And then next time, we're even going to have more fun